transistor circuit. Now, moving on from our input and output devices and our potential divider circuits, these all come together for our process part of our electronics. So we've looked at the input devices such as LDR, we've looked at output devices such as the LED, and we've looked at potential dividers where you have two resistors in series. The LDR has resistance, this is a variable resistor. These two resistors in series will share the supply voltage coming from our power supply. Now at the moment the circuit is off. I've attached the voltmeter, and again this should trigger your memory. When you were doing potential divider questions, one of the relationships was always to calculate V2. So if we class that as R1 and that is R2, then the voltage across R1 is V1 and the voltage across R2 is V2. And it was always the voltage across R2 or V2 that you were asked to calculate. Now the reason being that this device here, well actually in this little shape here, circuit symbol, that's for a transistor. Now a transistor is an electronic switch. Now like any switch, light switch, any other type of switch, it can be on or off, and at the moment it's off. Now when I switch the circuit on, you can see there's a small voltage registering, 0.1 volts. So that's V2. Now that is the voltage that will eventually, when it increases, draw a small enough current through a certain part of the transistor to switch it on. And we will know the transistor switched on because the LED will come on. Now the way I've set this circuit up is using an input device, LDR, which we know senses changes in light level. And the little term LURD, which is light up, resistance down, obviously goes in the other direction. If the light level drops, the resistance will go up. Now at the moment, the share of the 5 volts, sorry, not 5 volts, I've put 3 volts across this circuit at the moment. The share of the voltage that the LDR is getting is only 0.1. So the resistance 1 is at the moment receiving the remainder, 2.91. And the transistor circuit's off. Now what I'm going to do is, this is a sensing circuit and it will sense change in light level. So I'm going to cover the LDR to make it think that the light level has dropped and it's all of a sudden got dark. So I'm going to cover it with my finger. And what you should see very faintly is, you can just see the difference, the LED lights. Now the LED lighting says that the transistor is switched on. So whatever I've attached this transistor circuit to will now be in operation. The LED is only there just to indicate that the circuit's on. So when the voltage is small, or V2 is very small, the current is such that it will not switch on the transistor. However, when I increase the resistance of the LDR by covering it, the voltage rises to about 0.6. The accepted value for a transistor switching on for your SQA National 5 physics is approximately 0.7. So 0.6, again, not the most accurate set of devices, but it does show that when the LDR is covered, its resistance goes up, as we previously discussed. Its share of the 3 volts goes up to 0.6, which is large enough to operate the transistor and switch on my LED. Now that type of thing, like I said, try to think of a device that you could want to operate when it gets dark. So it could be, if you were fancy enough, it could be a set of automatic curtains in your house. So when the light level outside reaches a certain level, it triggers the transistor, which then operates a system to close the blinds.